Okay, this is 4.2, day 2, and we're going to be graphing quadratics in intercept form. We've only worked with standard form and vertex form. So intercept form looks like this: y equals a times x minus p times x minus q. And the x-intercepts are p and q. Now, this form only works for parabolas that have at least one x-intercept. Okay, looking at the example y equals a times x minus 1 times x plus 2, I know that my x-intercepts are going to be 1 and negative 2. So opposite of p and q are the x-intercepts. So with this example, we don't know our vertex yet, but we do know one thing about parabolas that can help us, and it's that they are symmetrical. So that's what the second bullet point is saying, that the axis of symmetry is halfway between our x-intercepts. So we need to know this equation: x equals p plus q divided by 2. And that's telling us where our line of symmetry is. But more importantly, we remember also that our line of symmetry goes through the vertex. So this equation helps us find the x-coordinate of our vertex. So that's important. That should be in your notes. And again, if the graph is opening up, then we know that a is positive. And if the graph is opening down, then we know that a has to be a negative number. First example is y equals 2 times x plus 3 times x minus 1. So the first step in graphing these is to find the x-intercepts. And if we remember from the slide before that the x-intercepts are opposite p and opposite q. So we have an x-intercept at negative 3 and 1. Keep in mind that our y value is 0 because on the y-axis, on the x-axis, y value is 0. And the next step is to find the x-coordinate of the vertex. So remember, we need to use p plus q divided by 2. That means we need negative 3 plus 1 divided by 2, which gives us negative 1. Now that we have our x value of the vertex, we need to find the y value. So let's plug in x, negative 1. Now we know that the vertex is negative 1, negative 8. So I can start to graph here. I have negative 3, 0, and 1, 0. My a value is positive, so it's opening up. And we know the vertex is negative 1, negative 8. I'll finish off the parabola. And here is a little better picture of what it should look like. Okay, I would like you to try this one on your own, so pause the video and follow the steps. So good luck. Okay, you should get something looking like this with the vertex at 5, negative 4, and x-intercepts at 3 and 7. And here may be a better picture for you if you want to copy it down. Okay, now we're going to look at a real-world example, since some of you are wondering how parabolas are related to real life. This is a football example, but I can think of plenty of other examples where this can be modeled by different sports or even by different situations. So we have a function here for the flight of this ball, and we want to know how far is the ball kicked and what is its max height. What we need to do is rewrite our function in intercept form. So I wrote the original at the top, and here is intercept form. So for that first x, we just need to change it to x minus 0. Okay, now we can find our x-intercepts. So we know that p is 0 and q is going to be 46. And then we can tell from that, because our x-axis represented distance, that the ball was kicked 46 yards. Now we're going to try to find its max height, and that means we need to find the vertex. So using our p plus q divided by 2 to get x, we find that it's 23. And when we plug 23 back in, we're going to get, that should be 13.8. And so now we know how high the football traveled. If you're interested in more real-world applications, come see me and we can go over some. I would like you to try this one on your own, so pause the video and good luck. And your graph should look like mine. Check over your work. And here is another picture of the graph. So come with your questions tomorrow, and see you then.